Alright, so the last time we left, we had our test passing and so on. The only problem on our pull request is that we are missing a few tests. We are missing some coverage, and more precisely, we are decreasing the total test coverage of the project of the Julia package by adding our features. So it means we need to cover more things. So we'll be using CodeCove, which is an automatic tool based, so leveraging Travis CI to get some information on the code coverage. And with this, we can get information on what are the misses and what are the tests that are correctly checked. So for example, here we have some tests that are not checked all the time. So here we have a double method, and this one is not tested. Maybe we should just remove this one because this is the subtype of this. So we'll start maybe with that. So we are in the project. So that's in test, and then test. Which file it is? SimpleWeightedGraph. No, that's in source. SRC is SimpleWeightedGraph, and that's at line. Okay, so here instead of this, one thing is we can just use any subtype of SimpleWeightedGraph is not directed. We don't need this because this is redundant with the initial docstring of a isDirected function. So we can just remove this, and then this is redundant because this is encompassed in this one. Okay, and then this is now also not required because there is a fallback for G, and so the fallback for this G, where G is a graph, is calling isDirected of type of G, or if we have a G here, a G like this, a big G. So there's already a fallback which is an line graph, so this means we don't need this anymore. I'm still gonna check maybe that this is the case. I think I already downloaded LiGraph somewhere. LiGraph.jl, yes. It might be in interface, I think. Is directed G. Yes, here we are. So that's the fallback here. So isDirected of any type G, where G equals isDirected of the type itself, and then this one is not implemented. Okay, so the one any graph has to implement is directed on the type itself. Cool. So that's one thing we're ensuring. So it means we can just simplify everything by removing unused methods. Okay, so that's the first step. Okay, we haven't tested getIndex on G with an edge, and we need to do that. Okay, so this will require a new test. SimpleWeightedGraph. We're looking for G. Yes. Okay. So what we can do is also for edges of G, and we're going to test that G of E and weight is approximately equal to 0. So with that, we are testing the second method, the second getIndex method, which is with G at the edge instead of G at the index of the source and the index of the destination vertices. Okay, So with that, yeah, we'll just test first, and we're gonna verify that we don't have any misses that we could avoid. We didn't apparently test this one, and that could be a good thing to do. So this is supposed to create a graph of type of integer type t with a default on float. Okay, tests are passing. Okay, and maybe it should be in another test file. Connect. No. Now I guess this is fine here. So I guess we can just, where should that go? So we're basically gonna test that the constructor is valid. So for t in, so this has to be integer type. Do 8, 32, and then int 32, let's say. So for these two, g equals test, no, g equals the weighted graph of t, and then test that g is abstract graph of t. That should do it. So yeah, it's an abstract graph of t, and it's also a simple weighted graph of t. Okay, yeah, the integer goes first, and then the float. 64. Yes, like that. And then, so that's the default, and then for u in, let's say float 32, float 64. Yeah, we already, yeah. Do we have some float 16? I'm not sure. Yes. Because 64 is already tested. No, that we don't have. 64 is already tested, so we might do it on some more exotic ones. Oops. So we're testing the second constructor, which is t and u, where t is the integer and u variable. Okay. And in that case, so g is a simple weighted graph of t and u, and then g still has to be an abstract graph of t, and g is a simple weighted graph of t u. Okay. Yeah, maybe that should also be a test set. Types constructors. Yeah, we should do it for comprehension here for the test. Test a type constructor. T for t in. Okay, that should do it. So type constructor t for t in all of the integer types. Yeah, u int, yes, like this. that should do it. Let's run our tests, and we should be fine now. I still feel that maybe simple weighted graph and simple weighted digraph or digraph should be merged, and the direction should be just one type parameter, but it means that simple weighted graph itself, the type, does not determine whether it's directed or not. You need this. You need the type parameter with it. Oh, do we have an error somewhere? Yes. Let's unzoom a bit. Wait, I'm always getting confused with the order of the two. Simple weighted graph type t int and float 16. So on the first one, and this is, so it's taking them in the other order. Let's check. TU, and T is the okay, T is the integer, it goes first, and U is variable, it goes second. And we did T, the integer goes first, and U, variable, goes second. I don't see how this is a problem here. First, is it in our tests? No. Is it somewhere here? Let's resume. Okay, so that's the constructor that's being called. T is the integer, fine, and U is the real. Okay. Oh, and it's calling UT. Okay. So the order is reversed. I don't know why. So this means T. This should be like this. Yes. Putting the first parameter as the real and second parameter as the integer. Okay. Yeah, I'm not sure this is ideal. It's fairly confusing to reverse the order between the arguments you get and the type parameters. Alright, let's test like this. Yeah, also I'll use this moment to refactor as we did before. Shorter is better. Maybe this is a bit too long, I'm not sure. Nope, still an error. Okay, so it's now in this one. Test through exception. Okay. Oh, yeah. Float and T. Float and T. Okay. Why did it error? G is simple weighted graph float T. So can we're supposed to be able to do that. Oops. Simple weighted graphs. so this constructor here has a problem. Simple weighted graph takes the int type, and then the float. So float 16 and then an int 16. Yeah, that's correct. So this means that here there's a problem, because t is the integer and it's supposed to go first, and then u the real. Okay, so that's a good thing. We could catch the error with that. I hope we did not introduce it in one of the previous streams. Okay, so anyways, this means this was initially correct here. T goes first and u second, also in the type parameter. Okay, great thing. Yeah, maybe we introduced the error. It's very unlikely that this error could have stayed, unless not tested, because this is just not correct. This is not even accepting to create the type. And this looks better for now. Let's not be too optimistic. Okay, perfect. This is now passing. And I think we have covered the test we wanted to cover. So we covered these two things. Simple weighted graph out of a simple weighted graph is just copying the weights. Yeah, in that case, maybe. Yeah, I think there might be an error here also. The simple weighted graph. Do we delete this one? I'm not sure. Still in the same file, and it's 31. Because no, that's this one. TU. No, okay, yeah, this is copying the weights. Yeah, I'm not sure this is correct here, or at least this should be tested, because we said that internally the weights are transposed, but now we're passing to a simple weighted graph the weights here. So I guess the two problems with this one is it's ignoring the integer type t and u, and second, it might untranspose correctly. I will see. Yeah, maybe we should add a test first to make sure. Getting weights. So where could that be? Type constructor, yeah, I guess here. Typed constructor. Getting weight not here. Yeah, it's kind of a copy here. Okay. Test. Oh no, so this is already tested. So simple. Oh no, this is for simple graph. So we want the same thing for simple weighted graph. Simple weighted graph of cycle path, let's say. Cycle graph, sorry. To equal simple for simple weighted graph. So basically calling on itself, yeah, like this. This should be valid. Okay. Let's run the test. And I think it will not be valid because here this will transpose the weights themselves when taking them, and they're already transposed, so there should be a permute equals false, I think. Okay, no, I don't understand what's going on. Maybe I should make sure that which one is called in that case. Yep. I think I should reload maybe, because I changed the package. Using my graphs, simple weighted graph. Where's this constructor? 37. So it should be 37 of simple weighted graph. Yeah, that's here. How does this work? Simple weighted graph of a matrix. So this is calling this one, okay? Because we are, this is a sparse matrix, or a sparse matrix CSC. So it's calling this one. And then, sorry, yeah, of course, we don't have permutes. We don't have a permute business in the undirected case, that's why. Okay, I got confused for nothing. Anyways, that's one more test we added, so one more reason to be reassured about what we did. More tests. And constructors. And type parameters. Still fork. Okay, so I guess we covered most of the things we did not cover before. This one, how come this one is not covered either? I feel like it's covered. Well, I guess with a modified test now, this should be covered. So we'll wait for CI to compute, then to pass the info to Codecove and get the coverage information, and then we'll see if this is fine or not. So we are still missing a bit of coverage here, and yeah, really almost nothing. And this is due to here, this is considered untested for some mystery reason, so Codecove is still not happy. And this looks like it's the last thing, because all the other things were already not tested before. Yeah. So the thing we can do is here, there's one thing that's still not tested correctly, is that we are still using simple weighted edge everywhere in the test. Let's go back to the project. Oops. Simple weighted graphs. Test simple weighted graph. Yes, getting weight. Oops. So here for E in edges, sorry. So this edge here is of type simple weighted edge, and we should convert this to simple. We could convert this to a simple edge. here, use getIndex here, like that. Okay, so like this, we are testing the method with both a simple weighted edge and a simple edge on the get information, because the only thing we need is source and destination. We don't need the weight of the edge itself. Okay, so let's first test this, and at the same time I'll just commit this, since this should work. I'll commit it, but I'll not push it yet in case I need to append something to amend, sorry. So add test for different edge type. And we just wait for the test to pass here and we should be fine. Okay, cool. So we can just git push. Alright, and again we're just gonna wait for Travis to pass, to check the test, and then to send the result to the code coverage tools. Okay, and this finally looks good to merge. We just refresh this, and that's the pull request itself. And oh no, we still have somewhere something which is not green yet. Everything is accounted for. Okay. Yeah, we must have some minus somewhere. Yeah, okay. I'm not sure if it needs refreshing or something. Okay, no. Now this thing is already tested. It feels like it's not updating correctly for pull requests. Yeah, okay, that's the number of addition and deletion. And what I want to see is whether I have some, yeah, misses. Like misses. These I guess don't count. Overrides we didn't change at all, so it's not us. Yes, absolutely not us. And then simple weighted graph has 3 misses. Simple weighted digraph, maybe we changed something here. Oh, yeah. Okay, so this constructor here is not tested, and that's exactly the same thing as we did for simple weighted graph, so the undirected case. And here this one is taking the matrix and converting it to a sparse matrix. Okay. Yeah, maybe we should test these two just for a form. Oh, same thing here. We have t and u where t is integer and u real, and yeah, this is not correct. Okay, so good thing is we found some errors in these tests, in this non-covered thing. Okay. Okay, let's go. Tests and SimpleWeighted graph. Where was that? Oops, not again. Type constructor. Okay. Yeah, we'll do the same thing for not here now. We'll just do the same thing for SimpleWeighted digraph. So it also has to be DJ is SimpleWeighted digraph. Okay. And then the same thing here. SimpleWeighted digraph. Abstract DJ is an abstract graph, and DJ is a SimpleWeighted graph. SimpleWeighted digraph. Okay. So that's the first thing. We're testing the constructor with type parameters. Now for digraph. And then SimpleWeighted digraph out of a cycle digraph. Yes. For SimpleWeighted digraph. SimpleWeighted digraph. Cycle digraph of 4. Okay, so this is testing the constructor by copy of another digraph, which is maybe already, no, yeah, it's this one exactly. And it's testing that the two results should be identical. Then so this is tested in the loop we just did. This is already tested also. So we tested these 3 things. We also need to test from an abstract matrix, so not from a sparse matrix. What we can do is SimpleWeighted digraph of adjacency matrix. So the adjacency matrix, this is going to be a sparse matrix, and then we take a dense matrix out of this. SimpleWeight, and this has to be equal to this. 1, 2. Okay, that's the first thing. And then we had this this error somewhere with the t and the u inverted. Tu, yes, this is supposed to be tu also. So in SimpleWeighted digraph 58. Zoom in. SimpleWeighted digraph 58. Tu, or yeah, we'll just also normalize things here. Space equals simply of t and u. I guess it's a bit confusing that the order is reversed from from the matrix, where for sparse matrices you have the type of the element, which is either float or anything, and then the type of the integer indexing it. Okay, and now we need to test that. No, this is also tested in this loop, in type constructor. Yeah, maybe what we can do is, yeah, no, we're fine. We could remove our test here and see what's going on if the test pass. So the tests were passing. And the test should now be passing, but we modified this, and they should be failing if we hadn't modified this line. Still have no method. Interesting. Oh, where do we? Huh. Close. Okay, we are calling with a true somewhere. At this place. Let's see what it looks like. Oh, did we do that? I hope not. And also maybe we should copy the weights here. Yeah, I will feel a bit more comfortable copying the weights to be sure that, because otherwise I think if we mutate one of the graphs, we're mutating the other, which is not a thing we want. And here, this should be a simple comma here. Okay. So while we're in the test, I'll check that there is nothing shocking here. Maybe we'll add a test for copying a graph and then mutating the initial graph and seeing that the other is not corrupted, let's say. Copying graph copies matrix. Okay, so from here, let's create. So we need to do it with both graph and digraph, I guess. Oops. So G equals simple-weighted digraph. Simple-weighted digraph of J. So it's a cycle graph. It means there's an edge from 1 to 2, from 2 to 3. Let's add an edge on the initial graph from 1 to 3 with weight 2.5, and then we can test that G of this one at 1, 3 and value weight. This is supposed to be not equal, but oops, approx equal to the initial value. I already have some few tests just for documentation. So before adding the edge, this is also the case for DJ. Oops, sorry. And DJ2, okay. Then we add the edge. And then for the first one, this is now 2.5. But the second one is supposed to stay at 0. Okay, our tests are passing. Now this test should be failing, while in fact it should pass. The borrower is this test at the end, so we'll run everything before having this test run. So when this test is failing, we'll add a fix by copying the weights when we create the new graph. Considering each graph should have its own weight. Wait, what? Maybe this is already copied. There's a permute dim. Yeah, but we're not using permute dim in that case. If permute equals false, we are supposed to use the same adjacency matrix. Let's try this in the REPL. Using simple weight graph, light graph. Okay, so we create the two. And so so was it copied or not? Yes, so if I do the add edge, that was in the test. Oh no, that's not a test. That's why. I think, yeah. Yeah, if we do this now, this should fade. So using test. Yes, now this is fading. Perfect. Oh, what perfect. Yeah, it makes sense. I was thinking there was a copy somewhere that I hadn't seen or that was sort of implicit, but no, it seems so the test will now be failing. The thing is, I hadn't put tests here, so this was just computing a true value but doing nothing with it. And now we're actually testing that we're getting a true value. And so this is gonna fail at this point here. No, at this point. Yes, DG2 is supposed to stay at 0, but since they share the same matrix, it was also set to 2.5. Wait, this was not failing somehow. That's odd. Did I? Oh, I did not save the file. It seems. Okay, yeah, perfect. So now this is failing. Okay, so with this in mind, we can now do as was suggested also by Simon on the pull request, and no. If we have if we're permuting, so this is creating a copy already. Otherwise here, we need to copy the adjacency matrix, but we don't want to copy it every time. Bar is, yeah, we don't want to copy the matrix when it's passed to us because it's likely being created just for the graph. But in the copy constructor specifically, so the one we were working on, so this one, this needs to be copied because otherwise two graphs share the same adjacency matrix, and this can cause some serious bugs. So we can just call copy here. And simple weighted graph or simple weighted diagram. Wait, what's the difference? Oh yeah, that's exactly the same thing. Oh no, this is actually calling this is calling the constructor of matrix. So I guess this is doing a copy. We'll see. So we'll do it. We'll redo the same thing. Or maybe not. No. We'll just free. We'll just create this. Call this other constructor. So we've t being int, u being float. Oops. Okay, and then we'll be adding an edge on 4 to the initial one with value 3.5, and then we'll be testing that value at 1.4 is 3.5 for the initial one, but for the second one, for the third one, 1.4 is supposed to be 0 because we're not supposed to share the same matrix. Okay, let's run the test now that we've fixed things. And also, I think we will need to do the same thing for a simple weighted graph. So let's see, I think this here is a copy already. Oh, no. Yeah, we might want to test this manually. So m is this. Oh, I did not load using sparse array. Okay, and then m2 is sparse matrix C of float 64 and int of m. Now m1 2 equals, let's say pi. So m now is this and m2 is that. Okay, so this is not a copy here. So we need to copy it also here. Copy. So I guess this is just sharing the pointers. The pointer to the columns here. Okay, so we'll need to copy it explicitly. Yeah, let's rerun our test. And this should be fine now. I don't think we have any more. No, we don't have any more constructors. This one, but no other one using a matrix. I will just, again, some minor formatting here. Okay, if the tests are passing, wonderful. I guess I'll just quit. Quit this one and commit. Okay, constructor to avoid let's say shed mutations. Shed matrix mutations. Okay. Alright, this is fine. The tests are passing here. Yeah, maybe we should. So this is assuming here that adjacency matrix is yeah, it's a bit of a bother because we don't know here if adjacency matrix is giving us a view, some sort of view of the graph, or if it's giving a matrix that's computed specifically when calling this function. If it's a view, that's a bother because we're constructing a new graph out of the matrix of another one. So if we mutate one of the structures, the other one's going to move too, and we don't want that. While if it's constructed just for this, we don't want to copy it because we will be creating the matrix twice. Maybe, yeah, that might be a broader issue with the API here that we have to address, which might be, should adjacency matrix be some throwaway that is computed at the function call, and then users can do whatever they want, or is it a view and it should not be touched and it should be copied if people are about to mutate it later? The two conventions could be okay. It's just we need one. Actually, there might already be one in that graph. JS matrix. We just check the documentation for this. Yeah, maybe we should not specify the data structure because some matrices could be dense. You don't know. Non-zero values indicate age. Okay. User may override the default data type. Okay. Okay. Yeah, that should also not be in the abstract graph. It should be specifically for simple graph maybe. Okay. Do we push? Yeah, I think we pushed. Okay, so again we're gonna wait for Travis, but things look pretty good now. Maybe we should do the same with a graph now. So we might do the same simple trick. Oops, yeah, a bit too big here with simple weighted graph, cycle graph, let's say. Okay. That's gonna be G2 test. Oops, no. G130, 130 at edge 13. Same thing. And then here with the other constructor, edge 1. Oh, yo, I think we need 5 here because otherwise 1.4 already exists. Yes. Add edge G 1.4. Okay. Okay, this looks legit. We don't need that here. Approximately equal to 0 is fine. Less is more. Let's not add coma when we don't need it. Okay. So let's rerun the test. test. In the meantime, we can check what did. Do we have? Is this linking to GitHub somewhere? Nope. Let's go back here. The tests are still not happy, it seems. Or is it still computing? We're still missing. Oh, diff hit. Okay. Is that the previous one? No, it's. Yeah, it's master, so I'm not sure what it's unhappy about. Codecov patch. So we're still missing some coverage, or we're still losing some coverage, let's say, but I can't see where. Yeah, overall we're just increasing the coverage everywhere. So we should not have trouble. Oh, and our tests are failing. Oh yeah, okay. So this means we are. Oh no, that's not right. G is okay. Oh, okay. No, I see. We copied G2 where we should have copied just G. We should not have. Yes. Okay, that's better. Yeah, maybe I should have done this in another test and not copied everything, not the whole block. But well. Okay, so the last thing will be to try to figure out where exactly we're still missing some of the coverage. Simple weight digraph. So this will be in digraph. Yeah, this one we said we could just subtype it, and this one we can remove, and that also can be removed. Okay. I think we did some tests for this one. That's odd. I don't know why it's not recognized as legit. No, we still failed some tests. G2. Okay, yeah, this makes sense. So this means instead, so G2 has a weight at 1,3 when we added one at G. So it means it's not copying the matrix, it's just using the same pointer. So that's something we need to fix. Simple weighted graph. Nope. Okay. Yeah, that's so here is just taking the matrix and using it directly. What we want is you're doing this except when copying a constructor. That's still fine. Simple. Yes, here. Here we need to copy the matrix. And same thing here. Okay. And that's it. The test should now pass. So I hope, yeah, this should now be fine, I guess. The only buffer I have is where are these tests that are not covered? We did cover almost everything, I guess. Yeah, it's telling me that it did not test the things for G. Wait, but we did this. Okay, cool. Tests are passing. That's really a good thing. Yes. Yeah, we did test it for G, which is both either a simple weighted graph or a simple weighted t graph. So we tested with E, and then we tested with simple edge here, which is an abstract. Yeah, maybe, I don't know, maybe testing and asserting that this is an abstract edge, but it doesn't make sense. It's just ugly for nothing. So I guess we could just consider it a failure of code curve here, even if it sounds a bit bad faith. All right. So we added copy constructor, copies matrix. Okay. So we both added some tests for the undirected case, and we fixed the corresponding implementation. So this should be fine. So now I think we have everything. So we have all the fixes made, and we have also increased the coverage. Definitely, we have tested things that were actually buggy still. So after hunting for a while in Cutco's interface, I finally found that the diff seems to be here. So we seem to have some coverage missing in that part on SimpleWeighted graph. So we're gonna check the equivalent file on the pull request. Graph, SimpleWeighted graph, to see what exactly we did change here, if we did any. Let's see. 5 changes. Okay, that's the other one. That's the gel. No, we didn't. Oh yeah, we did change the file. No, we didn't change the file because we changed the 2 source files and the tests. So it's showing us something that we did not modify. Great. Maybe we should, did we merge master? I think we did. Yes, we did merge master, so we don't have any excuse here. Just in case, we can check src. So we're importing things from diagraph, okay, exporting that. And then we are strict. Okay, we're defining the abstract type here, okay. That's fine. Convert. Maybe we should skip some lines here. Interface. Okay, so maybe some of these functions should be refactored. Some of the things we did refactored into abstract simple weighted graph. I'm not sure. Vertex, okay. here. I'm not sure these constructors should even be there. Simple weighted digraph. Okay, yeah, I see. Because you need digraph and graph for this. Okay, we did not modify this at all. It's just telling us that this is not covered. So if we take a digraph and turn it into a graph, it's gonna just remove the direction of the edges. But if we do the other way around, this will copy the weights in the matrix like this here. So take the transpose and add it to the normal weights. Okay, so it's complaining specifically for simple weighted graph from simple weighted digraph. So this one, yeah, this line. But this, since it's already on two different lines, let's just write it as a multi-line function. Okay, so same thing here. This is, we might be using the same matrix under the weights. That's interesting because this here, no, this is doing a copy, so we're fine. So creating a simple weighted graph from a simple weighted digraph. Okay. Oh, and this is the same thing as this. I'm not even sure that two should exist. Multi-line function again. So what can we do here? Oh, interesting here. Maybe we should copy the matrix also. It's when we create a digraph out of a graph. So if we take a cycle and if we take a cycle graph, for example, and we create a digraph out of it, then the edge will be added in the two directions, so from 1 to 2 and from 2 to 1. So what we could do is create, in the tests, so it will be here. Yes, again. Simple weighted edge, simple weighted graph, not edge. So here, copying graph, copies matrix, okay. Do we do the copy? No. So this will be buggy here. So let's say that let's start from scratch. So G is now a simple weighted graph. Simple weighted graph of 5, and BG will be a simple weighted digraph out of G. Subgraph here, I think we can create it like this. Let's check. Yes. Here, weights. Okay, all the weights are 0, 5. From 1. Okay, yeah, perfect. And so if we create a digraph out of this, this will add the weights. So for I1, 2, 4 test g.weights v of I plus 1 bar weight. This is supposed to be approx 0.5, while same thing for the directed version. I plus 1 is supposed to be equal to 1 because we're adding the edges in the two directions. Okay. And yeah, that should be it. Okay, that's the first test. And then the problem is when we mutate G, this will also mutate the directed one. So let's say that G dot add edge add on G 1, 3, which does not exist, with 6.5. Okay. And now test at 1 and 3. Wait, this is supposed to be 6.5 for G, and this is supposed to be 0 for the directed one. And the problem is now this will not, because we're just taking the weight pointer again. So the test will fail. Let's test that it's 0 before. So the test will fail, and then we'll fix it by correcting this one by taking a copy of the weight. And same thing when we have the specific, let's say the type specified version here. Okay, yeah, perfect. Yeah, we're failing here. So let's fix it with a copy of the weights. And then the same thing here. The comments, copy and directed. Okay, and the test should now pass. And I think this is the only thing missing in that Kotkov is complaining about. The rest of it we covered now with test all over. And yeah, this was the last thing. So yeah, the rest of it looks fine. Oh no, we are also missing a test for undirected with a type specified from directed. Okay. Oh, oops, no, still some error somewhere. Wait, this is I saved, right? stupid. Oh, wait. Why? Alright, no. In that case, it's not 1, it's supposed to be 0, 5. Because we're just taking the value. I'm not even sure we need that test in that case. And we can reduce the number of vertices. It's in the other direction that the 2 weights are added. This looks better. Yeah, perfect. And now, so we have this version, and we create its opposite, which is created. So a simple digraph out of a cycle digraph. This does exist. Yes, okay. With 0, 5. And now, if so, this will add no. Yeah, we can add an edge. So from, for example, the first one. No. I wanted to. So let's add an edge on DJ from. Or no, we'll just modify the weight from 1 to 3. With 0. Or no, from so there's one from 1 to 2 with 0, 5, and we'll add one from 2 to 1 with 0, 5 or 0, 6. And before that, we'll test that the weight before, so 2 to 1, that should be 0 before. Okay, we're not gonna test that it's, oops, we're not gonna test it's 0, 6 after, it doesn't make sense. We'll just trust it. And now we create a simple weighted graph out of DJ. And now the test that we want to do is that, so G at 1, 2 is equal to 0, 6 plus 0, 5, so 1.1. And then at 1, 3 is 0. Oops, no. And at, let's say 2, 3 is only 0, 5. So we're testing that it's copying. When we have one edge from 1 to 2 and one from 2 to 1, it should add the 2 weights. In that case, adding 0, 5 and 0, 6. While if we have only one edge in one direction, like from 2 to 3, should only have this weight. And when there was none, so there was no 1, 3 or no 3, 1, then it should have 0. Okay, let's test this. And then we should be good. So because there's a because there was a broadcast operation here, we are sure that we're not manipulating the same matrix anymore. We're using a different matrix constructed from this. Okay, perfect. So our tests are passing. We can commit construction from directed and reverse. So with this we have the last test, I hope, finally in place. So this will again increase the coverage. So we did not modify anything except the tests here. Okay, so let's hope the last commit will do today for these tests. We get on the on-cut coverage 2 last red lines, so to speak, so 2 last lines that are not covered. The constructor of SimpleWeightedGraphs with one specifier T only and an abstract matrix of real type U. So we just need to test this one, and then the second one will be the weights, get index of an edge. Yeah, I don't know why is this not tested. This is tested. Okay, yeah, maybe we can just add one more test for this. Yeah, I guess so. All right. So yeah, we don't need this. Let's go back to the test. It's always the same file again, and let's start with this one. So simple weighted graph with T. Okay. So we have a given matrix which is not a sparse one already. I think we had a matrix constructor here. Okay, yeah, we did it already. So the thing is, we have to do it also for a given type. So float 64. Oh yeah, let's do a float 32 to change. So it takes a matrix which is not a sparse one, and this should be equivalent to simple, like this with float 32. Okay, so these two should be equivalent. That will be the first thing, and the second one will be here, the weights. So how do we go about testing this, since it doesn't seem to like the test we already put? Index gets wait. Oh no, we don't use get index. We just use G of square bracket here. It's a simple weighted graph. Okay. Yes. So we create an empty graph with 3 vertices. In the case when it's direct, in the case where it's directed, sorry. So in any case, we add the edge 1, 2 here. How could we go about this? We could just test it directly, but this is very stupid. Like testing that get index blah blah is equal to G weights of destination and source. So yeah, we could go about matrix of G, okay, calculate as a float, approximately equal to g.weights at 1, 2. And yeah, this should be fine. Okay, and this should also do a test. Okay, so let's run our test first locally. I guess we can commit at the same time. Additional tests for coverage. Yeah, let's be honest about it. This is purely for coverage. Okay, I hope I haven't. Oh boy, just when I write just for coverage. Oh, interesting. This seems not to exist. All right, we can't. Yeah, we can't pass it only some float here. It seems. Oh, and that was maybe we should just remove this altogether. Oh no, yeah, this is not taking a float. This is taking the integer type. That's why. Oh yeah. So we'll just append here. Yeah, let's say in 32. Yeah, we're not passing the float type, we're passing the integer type here. Okay. And this should not be fine. So luckily I did not push yet, so I can just add my fix and commit and amend it. Nope. Wait, what? No method matching. Simple. Or you. What? Okay. Oh, we don't have this one. Okay. Oh, no, right. Yeah, I think. Where was it? 32. Yes, here. Yeah, here we need to specify the two type parameters. So, yeah, this is a matrix. So this should be float 64. Yeah, like that. So this room will definitely have been more about, on one side, bug hunting, writing one test and then fixing those tests. So this was not the most thrilling moment ever. But yeah, sometimes that's what developing is about. The method matching. How come no? Closest candidates are the empty one and no, but we should have one for that takes an abstract graph, I think. Okay, we can just create a graph out of this. So this is, yeah, maybe doing a bit too much work, but yeah, really not ideal. Yeah, it's not ideal, but well, we can cope with it. So the nice thing about these 4 comprehension in tests is that you have all the test sets well developed to see if it will be surprising that one of them fails and not the others, but yeah, at least you see them clearly if it happens. Maybe we should also reduce the number. We don't need all of them. Okay, and the test now passed. So we can add the tests again and commit command again. Okay, and push. No, still fork. Okay. Yeah, maybe we can reduce the number of tests because it's getting a bit heavy. So yeah. So how was it called? And yes, here. So we have, what's the biggest number? Yeah, we have only 2 float, but that many ints. We don't need all of them. Yeah, let's just 2 like this. This is 12 tests for each of a combination between the integer type and the float type, so this will reduce things greatly already. Reduce number of test types. Okay, and with this we should be good. I hope this will make Cutco happy. I think so, because we covered the 2 things that were untested. So this one and this one, yes. We added some extended tests for both of them, so you should be fine. This part is finally over. I have to admit I had to do a few more commits here with every time just few tests targeting specifically some parts that were not covered, like creating a graph out of a directed graph, then creating a copy with just another type signature, and checking that the 2 matched. And yeah, the last part was not that fun, but yeah, at least we have the coverage quite up, I think. Yeah, plus 4% compared to master. So this is pretty good. We now get a pretty good coverage, and I think we fixed a few bugs. So yeah, it's a nice thing to have. And we finally have our constructors done, and if we look at the complete diff of what we did, yeah, it's mostly a bit of syntax, but also simplifying a lot all the constructors that are exposed for this, and adding some documentation here and around. All right, so yep, that's it.